He was young.
Yeah, he just checked after.
Okay. So radical simplification is pretty easy. Do you guys remember the perfect squares? You guys remember what perfect squares are? What's our perfect squares?
What?
Not 5.
How bad?
1, 4, not 2. I don't know what I think. 9, 16, 25. So it's like if you take 1 squared, you get 1. 2 squared, 4. 3 squared, 9. Yeah? Okay. 4 squared, 5 squared, 6 squared. 7 squared is 49. 64. 81. Okay. So those are pretty good for now. That's through 10. So that's 1 squared, 2 squared, all the way up through 10. Obviously, you could keep going. So if we look at the square root of 25, is that a perfect square? Yes, it is. So when that happens, it's just 5. Easy peasy. Okay? We get a perfect square, nice number. If we have the square root of 40, is that a perfect square? No. So your process from here is to find the biggest one of these that goes into 40. So what is the biggest perfect square that goes into 40? 4. So if you do, here's the best way to do it. If you do 40 divided by 4, what do you get? 10. Okay? Now, this is where it can get a little fuzzy, okay? Because we don't know for sure if 4 is the biggest. Maybe 16 goes into 40. We don't really know, okay? Here's how you do it. If you look at 10 and you say, oh, there's a perfect square that goes into 10, you haven't found the biggest one. Is there a perfect square that goes evenly into 10? No. Okay, so if we did 10 divided by 4, we get a decimal. If we do 10 divided by 9, we get a decimal. 1 doesn't count. Okay. So that's how we tell. So we know that 4 is now the biggest. Then we look at 4 and we're like, that's a perfect square. Square root of 4 is 2, so the answer to this one is 2 square root of 10. So you're just finding the biggest perfect square that goes into each one. All right, 72, is it a perfect square? No, but we need to find the biggest, okay? So let's start with 4. If we do 72 divided by 4, we get 18, okay? Is there a perfect square that goes into 18? Like because I know if I do 4 times 18, I'm going to get 72. But is there a perfect square that goes into 18? 18 divided by 9 is 2. Yeah, okay, 9 is perfect square. So that's not the biggest. Okay, so then we go to our next one. What if we do 72 divided by 9? Yep. 9 times 8 is 72. But is there a perfect square that goes into 8? 4. Uh-oh, we don't have the biggest. Okay, yep, 36. So if we do 36 times what? 2. Okay, is there a perfect square that goes into 2? Well, 1. It doesn't count. Okay, so now we know that we have the biggest. What's the square root of 36? Yep. So we have 6 square root. All right, square root of 50. Is it a perfect square? No. Which one goes into? What's the highest one goes into it? 25. That's kind of an easier one. So we would do 25 times 2. Now, when I'm writing these, notice I'm putting the square root over my number. Okay, because it's still a root until we take the square root of it. So now that we can take the square root of 25, what do we get? 5. The square root of 25 is 5. 5. You tracking with me? Coming back to you? All right, let's do some more. Now, you're going to notice that there's a number on the outside. Not a big deal. You did the same process. It just has something else at the end. So when we look at the root, square root of 9, is 9 a perfect square? You bet. Okay, what's the square root of 9? 3. Okay, so now it's just 2 times 3. It was 2 times the square root of 9, but the square root of 9 is 3. 2 times 3 is 6, so that's your final answer. Okay, number 6. I'm sorry, yeah, number 6. So we have 2 times the square root of 50. Is the square root of 50 a perfect square? No. Okay, Okay, so I'm going to leave my 2 out here. He can hang out. Now I need to break down the square root of 50. Tell me the biggest perfect square that goes into 50. 25. So we're going to do 25. Square root of 25 times the square root of 2. What can I break down from here? The 25, the square root of 25. What is the square root of 25? 5. My last step is to multiply those coefficients. 2 times 5 is 10. Okay, now on number 7, okay, this is a little bit different. When we add or subtract radicals, there's one big rule. They have to have the exact same base. Meaning, when we look here, these both have a square root of 3. That means we can add them, okay? So if we just add the coefficients, negative 5 plus 2 is, negative 5 plus 2, negative 3, so we get negative 3 square root of 3. It's almost like doing this, okay? You would tell me that's negative 3x. I know you would, okay? It's the exact same thing when you add or subtract radicals. You just treat them like an x, as long as they're the same, okay? So when we get here, can we add those? No, because one's a radical 5, one is a radical 3. That's prime, okay? Can't do anything with it. Okay, what I want you to do is, since we just did radicals, flip it over. There's a practice section with radicals. It says practice, and right under is radicals. I want you to go ahead and do that by yourself right now. I'll give you a couple minutes, and then we'll do tricks. Okay. If you need to write those perfect squares at the top of your paper, do it. I'm going to leave them up here on the board, but you're always welcome to write those on your paper. Okay, guys, sorry about that bottom row. I don't know what my board's doing. But you can go ahead and read those. Are there any that I need to go over with you? Any that you're not so sure about? Okay. Now, 288, that had a bigger perfect square than what we have up here. So if we do 11 squared, what do we get? You may know. 121. 12 squared is 144. Okay, and 144 is the biggest perfect square that goes in here, 144 times 2. Okay, so that one wasn't necessarily up there. So if you didn't get that one, I understand why. Okay. Any questions, issues on radicals? We feel okay about that? That come back to you a little bit? Okay. And keep in mind, these are just skills that we're going to use within what I'm going to teach you with vectors. So it's just kind of brushing up on those skills before we get started. They don't need to be perfect. Okay, we'll practice this as we go as well. Let's go ahead and go back to the front. We're going to do our radicals here. I'm sorry, our trigonometry. Okay, so if you remember right, SOHCAHTOA, okay, it's S-O-H, C-A-H, and then T-O-A. That's SOHCAHTOA. So the S stands for sine. Okay, the sine, when we find that, we use the opposite side over the hypotenuse. That's the O and the H. Cosine is the C. A means adjacent, which is right next to. Okay, H is hypotenuse, and then T, tangent, opposite, adjacent. Okay, that's what those stand for. So if we look, okay, we're going to do the sine of C. So sine, okay, that's the SOA part. Okay, so sine of C, this is how we write this. Sine C equals okay. Now, if we look at side C, we want the opposite O over the hypotenuse. Does anybody remember which side is the hypotenuse? The longest, but it's also across from one angle. The right angle every single time. So it doesn't matter how it's transformed. Sometimes it'll be rotated. Okay, it's always across from that 90-degree angle. Okay, so opposite. What side is opposite C? Straight across from it. Okay, that's a bit of an error. 21. Okay, so 21 is going to be our numerator. This is killing me. Okay, and then our hypotenuse is which number? 29. Okay, you're going to need a calculator here. Okay, so that's what we have. Now, that's good and all, but we also need to know how to find the angle. Because really, the purpose of having the sign of opposite over hypotenuse is to find the angle measure. So we take our calculator, open that up, turn that on, and we're going to use something called the inverse sine, or sine inverse. And what that looks like, it's right on your calculator. Let's open it up here. It's right here. If you see sine, if you find right above that, we'll say sine to the negative first. That means the inverse. Okay, so you're going to hit second sine. Okay, my TI Inspire friends, you're just going to do SIN to the negative first. Okay, and it should work fine for you. And then make sure you have a parenthesis. TI 83, 84, it'll put that parenthesis in there for you. Okay. Then if we look at our notes, we had 21 over 29. Ooh, I forgot. Press mode. Press mode. Okay, TI Inspire, you should be fine on this. Okay. If you look here, it says radian and degree. We want to tell our calculator that we want the degree measure. We don't want a radian measure. Radian has to do with pi. We don't need that. We need the degree. So if yours is on radian, you need to go down, highlight degree, and press enter. Stop looking here. Okay, and then degree should be dark now. Okay, if you don't do that, it's going to throw some things off. Okay. Once you're there, press second mode. It'll take you back to where you were at. Questions on that? All right, so you have sine of 21 divided by 29. 6. Okay, which is 46 point, we'll say 46.4. Okay, you got to round that up. So that angle C measures 46.4 degrees. Listen. Okay. Questions on that? All right, so let's do the cosine. Cosine is the CAH part of the SOHCAHTOA. Okay, C stands for cosine. So we're doing cosine of angle C is adjacent. Now, the issue that can happen with adjacent is that sometimes people say the adjacent side is the hypotenuse by accident. So you always want to look at, okay, which one's the hypotenuse? We know the hypotenuse is 39. Okay, that's going to be our denominator. We want the adjacent side. So if you look at C, 15 is opposite C. Right next to C is 36. That's your adjacent side. Okay, so it's the side that's right next to your angle that's not the hypotenuse. We do the exact same thing in our calculator, but this time we're going to do cosine inverse. So I'm going to press second cosine. Okay, and I'm going to do 36 divided by 39. So I get 22 point, we'll say 62. 22.62. Tangent, exact same thing, except for tangent is the TOA part. T-O-A. Oops. So we're doing tangent of A. So what side is opposite? The O. What side's opposite? 12. This is our O. What side is adjacent? 35. Don't get tricked by that 37. The 37 is the hypotenuse. Okay, so we'll do opposite over adjacent. That's where we get the O and the A. Opposite comes first, so it's the numerator. A comes second, it's the denominator. Now in your calculator, you're going to do tangent inverse of 12 over 35. Okay, and I'm getting 18 point, we'll say 92. You guys getting 18.92? Yes. Don't forget to put your degrees on there. Okay, what questions do you have for me? Okay, so we just used trigonometry to find an angle. Now we're going to flip our paper over and we're going to use it to find the measure of a side. Okay, now we're going to do a side. Okay, so the missing side is going to be x. Okay, the missing side is going to be x. You just have to decide which trig function you're going to use here based on what you're given. So look at your angle. Okay, here's our angle, 59 degrees. Okay, 59 degrees. Look at x. How does x relate to that angle? Is it the hypotenuse? Is it opposite? Is it adjacent? X. That's opposite. It's straight across from. Okay? So this is going to be opposite. What's the 17? Hypotenuse, because it's across from that 90-degree angle. Hello? Oh, darn it. Okay. Yep. Bye. Okay, so what trig function are we working with when we have O and H? Yep. We're going to do the sign, so the SOH part. Okay, there we go. All right, so we're going to do the sine of our angle, okay, 59, equals, and then our opposite over hypotenuse. So opposite is X, hypotenuse is 17. Now, keep in mind, we're solving for X here. We want to find that missing side. How am I going to get that 17 out of that denominator? So I have X alone. Yeah, multiply. It's being divided, so we're going to multiply both sides by 17. Okay, so this guy will cancel out, and we'll have X left. On the left-hand side, we have 17 times the sine of 59 degrees. Okay, if we put this in our calculator, it's going to tell us that side measure. So I'm going to pull up my calculator, okay, and I'm putting in 17 times the sine of 59. It's giving me 14.57. That is the side measure. So now you have to know, okay, this isn't degrees. We'll just say units because it wasn't labeled. Okay, so X equals, oh crap, I forget what it was. 14.57. Okay, if it would have been centimeters, you would have put centimeters. Inches, inches. Okay, so do the next thing, we just have to figure out what kind of trig we're working with here. So if you look at X, how does X relate to 27? How does X relate to 27? Adjacent, right? It's right next to. And then what is 20? Yep, that's your hypotenuse because it's across from that 90-degree angle. So what are we working with here? Which trig function? Cosine. Okay, we're working with A and H, that's cosine. So you have cosine of 27 degrees equals, and then you always do the first letter A over H. So you'd have X over 20. Okay, to solve that, multiply both sides by 20. Okay, and we're going to put this in our calculator. 20 cosine of 27. I'm getting 17.82. And again, it's units because we're working with a side measure, not an angle there. Okay, last one together. All right, if we look at 53, how does X relate to 53? Kind of a weird looking triangle. It's turned a little bit. Is it opposite? Is it adjacent? Is it hypotenuse? What is that X? Is it touching the angle 53 at all? No. That's a sign that it's opposite. Directly across from. Okay. What about the 12? Yep, that's adjacent. Okay. If we look here, this unmarked side is across from that hypotenuse. So that's definitely, or across from that side, meaning it's the hypotenuse. O and A, that's TOA. Okay, that's tangent. So tangent of 53 equals x over 12. Multiply both sides by 12. So this is what we put in our calculator. 12 tangent 53. Just 15.92. Now, at the very bottom, okay, I want to do one of the questions with you because there's something that's a little bit different, okay, and it's pretty easy to figure out the difference here. Not those. Okay, so look at the very last questions, okay. I'm going to let's just do 13 together, okay. How does x relate to 51? What side is x? On number 13. That's the hypotenuse, because it's across from the 90-degree angle. Okay? How does 10 relate to 51? It's adjacent. Yep, it's adjacent. It's right next to. Which trig function is A and H? Oops. I think I heard it. It's cosine. Okay, A and H is cosine. So we're going to do cosine of 51 equals, and then it's adjacent over hypotenuse. So 10 over x. This is what's different. What do you notice it's different than the last three that we did? It has to do with x. It's the denominator. Okay? It's not the same problem. You can't just multiply by 10. Okay? Because it's not in the denominator. So I'm going to show you a quick way to do these problems. Okay? Because number 14 is the exact same way. Okay? Here's all you have to do. You don't need to know why. Okay? You probably can figure it out if you wanted to. You're going to switch the cosine of 51 and x. So you'll have x equals 10 over cosine 51. So when your variable is in the denominator, just switch them. Okay? Just switch them. And then you can put this in your calculator. So we have 10. So 15.89. Okay. I'll give you the last few minutes. We've got about 4 minutes left here to practice. Okay. Again, you do not have to have these skills perfectly down. This is just stuff that we're going to use when we get into vectors. So I want to make sure that you at least see it. Okay. Did both of these things kind of come back to you a little bit? Yeah. Okay. Good. 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 Thank you for being awesome while I was out. I appreciate you all. Makes my life a little bit easier.